lunch. We're gonna go ahead and get started here with our space panel. So as a reminder, so the Expo, the two themes that we've been discussing are AI and space exploration. Not the two of those things combined, although in the presentation by the Lunar Rights team earlier, they did show an application of AI large language models in a space exploration software. So sometimes those things converge, but today we're going to be talking specifically about space exploration. I have some awesome panel guests here, which I'll have introduce themselves. I want to double check that Kylel on Zoom can hear us. Are you guys getting him up on the big screen? Okay, Kylel, can you hear us? Okay, he can hear us. We can't hear him. We'll get that straightened out, and we'll get then we should be ready to get rolling. So give us 1 minute. Are we good? Okay, we can see him. Kylel, can you talk and let's see if we can hear you. Yeah. All right. Yeah. Okay, awesome. All right, well, let's go ahead and get started. So we're going to just start off with some introductions. They're about some of our awesome panelists here. So I'm just going to start here with Sammy, and let's just go Sammy, Jim, Kylel, and let's just get this ball rolling. So real quick, what you're going to do is give us your name, your job title, your degree, and let's just start with that. We'll get into more, but let's just start with that. Maybe not title, but like what you do in the space industry. Let's just go with that.
Just the one? Okay. Cool. So, hey everyone, my name is Sammy Mion. I'm an alumni of the lab. I've worked in the space world for 10, 11-ish years on and off. Started, working with a NASA scientist here at ASU, who's a professor, Alberto Bahar, way back when. And actually, I'll do the bio later. But most recently, I was project lead at Amazon Kuiper, where we were launching satellites into space. Did some work with Blue Origin as well. And I have my PhD in electrical and computer engineering and spent a lot of that working on space.
I'm Jim Rice. I got my PhD here at ASU last century. Yeah, I'm a planetary geologist, or the word I like is the old school word, astrogeologist. Primarily work on Mars and the Moon, and I was selected by NASA to be on the science team for the Spirit and Opportunity rovers 20 years ago. They landed now. Spent most of my career working on those rovers because they lasted forever. I'm currently working on Perseverance rover, and I'm a geologist, so I do a lot of field work in weird locations around the world like Antarctica, Iceland, Devon Island, and the high Arctic. And I'll leave it at that right now.
Okay. We'll come back to Jim. He's got a long history and experience. So, Kylel.
Yeah, for sure. Can you guys hear me though? I'm gonna check that real quick. Awesome. Well, yeah, my name's Kylel. I'm I guess I'm in along of ASU. It's kind of weird to introduce myself like that. I still have my old Luminosity Expo T-shirt for the first time. But I'm an alum from ASU. I'm also an alum from the lab. I graduated spring of 2022 with my master's in robotics and autonomous systems, and my undergrad in engineering with a focus on robotics. I now work at the NASA Langley Center, where I work for Team Sci-Fi, and that's an acronym. It stands for Scientifically Calibrated In-Flight Imagery. So we kind of specialize in taking like scientifically calibrated radiometric and spatial data for different launches, ascents, and like re-entries of space vehicles. So essentially, we have partnered with different NASA groups. We took a lot of data for like Artemis 1 launch and Orion return. We've had stakeholders from Blue Origin, SpaceX, and yeah, our whole kind of idea is trying to kind of maximize the uncertainty with like data that we collect from these like vehicles, so that we can like better assess their performance and things like that, and give that back to the stakeholders for them to like put back into their iterative design processes.
So a lot of the stuff that we capture is capturing like thermal and spectroscopy of these systems. So the scientists at these other organizations can better assess the fidelity of their models and of the materials they make their vehicles from.
Awesome. So what we're going to do, so the theme of this panel today is really to explore all of our panelists' experience in their work history in the space industry. So we're gonna do this in reverse order of what we just did. So Kyla will be back up talking about really how you first got interested in space exploration. So just walk us through that. So what I find interesting is a lot of students don't really even you might dream of being an astronaut at a young age or something like that. But then you basically are like, you quickly realize, okay, probably not going to be an astronaut. But then, in some cases, like what we have here, lots of opportunities to work in the space industry, and really rediscovering that. And I think that's something that's really interesting. So, Kyla, why don't you walk us through how you first got interested, why you're interested in it, and then how you got into the space industry?
Yeah, I guess let's say, I'll start kind of in order. My first like spark of interest was actually at the lab. In 2022, we had the big idea like challenge and stuff like that. And I guess before that, there was the Velos competition, which was like a submission for like the big idea challenge. That was before I actually joined the lab. So I wasn't part of the team that was developing that system, but I thought it was super cool with like my robotics and computer vision background. I was really interested in it. Like robot autonomy, I was very interested in it. And somewhere between like that project and the next big idea submission that we had, I ended up getting like picked up for an internship at the Langley Research Center. And that's kind of where I actually started a lot of my connections and ended up working where I do now. But in terms of like my inspiration, I didn't really have those kinds of aspirations as a kid or even in college and stuff like that. I'm like very goal centered and goal oriented. So it's kind of like I would have assignments and like things like that, projects that I was working on where I really just found value in like completing the project and like exploring that research. And it wasn't until I started working for like my internship and like the big idea and stuff like that that I really saw with space exploration, the like limits are really the horizon. Like you can really start to develop what you guys have seen a lot already, just systems and different approaches to different problems. And all of them are out of the box and there are no like constraints and stuff like that. And it really allows for you to have kind of like a lot of freedom in your research and freedom in from like research to design to implementation. All of that is really on you, and it really allows somebody who really enjoys that kind of work and everything, that kind of research, to just explore like any solution that they can think of and try to really nail down the best way to go about it. There's not necessarily like a right way of doing it with space exploration because it's still being explored. There's just like the best way and the most certain way. And I think that's really where a lot of my interests kind of came from. And after I kind of like honed in on that, I then started to like express it in my day to day. So that's why I like ended up working for NASA and stuff. And the research that I do now is very much so tied to that idea where I'm taking a lot of like practices that are kind of tried and true, trying to like novelize them and stuff, bringing a lot of computer vision and AI into like the spaces that I'm occupying so that we can kind of get smarter about how we're processing this data and kind of reinforce the tried and true with these new statistical and like data analysis processes. And that's like completely like valid. You should be trying to push the horizons and push what is and stuff. And that's what space exploration is all about. Yeah, I think that's the whole shebang, I hope.
Yeah, that's great. Awesome. Appreciate that. All right, Jim, so tell us a little bit how you first got interested in space exploration.
I'm pretty old, okay? So I grew up in the 1960s with the Apollo program as a kid. And that inspired me because we were in a race with the Soviet Union, former Soviet Union, to see who's going to win first people on the moon, you know? So I grew up watching this happen before my very eyes. I've always been interested in space exploration at least since I was 6 years old. Never wanted to do anything else. I have other interests, but that's what I wanted to have my career in. And I wasn't the best student growing up. I got real good grades in grad school because I was doing something I wanted to do, but if you saw my report card in grade school, you would think this guy's going nowhere. And I was shocked. My mother had my old report card when I was home a couple years back in Alabama, and it was horrible. But, if you get inspired and motivated, you can do great things. And I had a lot of help along the way. Like my parents encouraged me. I had great mentors and teachers. Had some that weren't so encouraging in high school. I can still remember their names. They told me I was too stupid. I would never work for NASA in my life. And I just kept that inside and made it a motivation force. And I'm very fortunate. I've done pretty much a lot of things I've dreamed about. The one I didn't do, I wanted to be an astronaut growing up. I was a finalist 2 times, so I'm a 2-time loser. I didn't make it in, but I got darn close. But other than that, I've done things on that trajectory, that career path, and it takes you places you'll never think you're going to go. For instance, I spent 6 months in Antarctica at a Russian research science base, scuba diving into frozen lakes down there. I never thought I was going to do that growing up, but the opportunity fell right in my lap because I was doing research here at ASU, my PhD, on ancient lakes on Mars, and they probably had ice covers on them, so that's how that all worked. And so I've been very fortunate to do all these things I've done. Like I said, I had a lot of help along the way, and I will tell you, if anybody wants to be an astronaut in here, go for it, because they got to pick somebody, and you never know. And I've got some good friends who got selected the times I didn't get in there, but somebody's got to fly into space, and somebody's, one of y'all guys in here could be going to the moon on the Artemis program or even to Mars, but it's really tough getting in there, granted, but it's worth trying. You got nothing to lose, the way I look at it. And I can now just shut up right now. I'm kind of rambling.
No, that's great. We could just listen to stories of your expedition in Antarctica probably for the next hour, which would be awesome. But we'll come back to that too, because so I've only heard a little bit of it, and it's super interesting. So, Sammy, tell us a little bit about it.
I mean, I'm happy to give Jim my time. I want to hear about space.
Yeah, there's that's a tough one to
Y'all got
follow.
stuff too, man.
They asked me if I wanted to go down there. I was like, no way. Okay. Let's see. So, how did I get involved? Well, for those of you who know me, I've always been the robot guy, right? I love robots, robotics. I've been in that world since I was a little kid. Grew up the son. Is this working? Can you all hear me? Yeah. Okay, cool. Grew up as the son of a physicist, so started tinkering, and by tinkering I mean breaking things early on. Loved technology, got involved with building robots, and was really just interested in the mission of exploration and discovery. It didn't matter what it was, just building something that could let you be and experience a new environment that you could never get to. Whether it was a small little basically roach bot that went exploring mouse tunnels in a house to eventually launching things into space. Got started working for a professor at ASU. I met him actually before I even came back in 2010, and he was building submersibles that were exploring the lakes in Antarctica. Yeah, and he actually got me started on working with drones, which were relatively unknown back then. This was before the big boom of DJI and other companies, and just, hey, here's a new type of platform we can use to expand our horizons and go to searching, learn. I remember the first time I messaged him, he was like, I can't talk right now, I'm in a volcano in Hawaii gathering some data. And I was like, that's so cool. And from there, just tried to work in every single field where there was a robot, from robot soccer to self-driving cars to, the submersibles. And the most fun I ever had was when I was working on things that went into space, because it was just so different from anything we had to deal with down here on the Earth. In grad school, the lab I worked with, we built processors that were sent up to the ISS that had to deal with radiation and bit flipping, and it's something I'd never had to think about or deal with until then. And so just the challenge and the ingenuity that had to be figured out, and we'd go and we'd learn from the professionals like Jim.
how do we bring this to modern technology? You know, how do you take a graphics card up into space, which is something you can't radiation hard back then. Now you can. You just send a Nintendo Switch up. And that was really cool. I will say the highlight of a lot of that for me was during grad school, I got to go down to Kennedy and watch a launch live. I got to watch something that I built go up into space for the very first time, and that was extremely special to me. And that's where I knew, like, it doesn't matter what I'm going to do next, I will always come back to space. And that's happened twice already since then. Most recently, working on satellites and satellite lasers, which was super cool. How many people can say they worked on space lasers, you know, without having been in the military? I'll stop talking now.
Awesome. Well, I want to also introduce Grayson on Zoom. So, Grayson, we just got started. Can you give a quick introduction, your name, where you work, your degree, and then what we're just talking about is how you got interested in the space industry. So, perfect timing. So, why don't you jump in?
Well, actually, so I'm an alumni from Arizona State University as well, and I was part of the industrial design program. I finished my master's there about a year ago, and I originally got into space through, well, Tyler brought me on when they were working on one of the NASA Big Ideas competition, and we were submitting a rover for the year. And I'll always remember, it was kind of funny. He goes, "Hey, I see you're also a rock climber." And I was like, yeah. He's like, "Do you know how to do rigging and like ropes?" And I was like, "Yeah, yes, I do. I used to be a guide." And he goes, "Do you think you could hook up a 200-pound robot to the side of a cliff and do that safely?" And I was like, what? And then eventually I found out we were doing the NASA Big Ideas competition, and that was a really great experience working with everyone. It was really cool seeing it come together. And I pivoted from outdoor gear design, and now I just say I do really outdoor gear design because I'm working at Honeybee Robotics, and I work on different technologies that are going to space, and our aim is for exploration as well as acquiring resources and staying up in space. So, for example, some of the tools on the Mars rover actually come from Honeybee Robotics, such as the rock abrasion tool, which is used to collect samples.
Awesome. And that actually is a true story that Grayson told. So exactly, word for word. Okay, so let's jump into the next question. This is one that I think we can spend some time on. So the question is, what is the most exciting advancement in space exploration? And I'll put that out there, and then I'll ask somebody to jump in. And that maybe you're currently interested in. Let's like talk through some of the most recent advancements. There's a lot of stuff going on right now in space exploration, from rocket technology, lander technology, exploration technologies, sensors. Let's like dive into that in a little more detail. So let's go to Kyle.
Still thinking. I just had an idea right when you called my name, so I'm glad I could think on my toes like that. But I guess a lot of my know-all of like everything, because like you're saying, a lot is going on and stuff is in R&D, and not everybody can read papers with code for like all the time throughout the day. So I think like my favorite is probably constrained by like what I do know. My group was like fortunate enough to partner with like SpaceX for their past 2 Starship missions. So we were out there, we collect like aerial data of like these ascents and reentries. I think that's something I didn't say before that kind of puts us in a different category. A lot of times that stuff is collected with the camera on the ground, but we actually put the camera in the air and put it on an airborne platform with like special windows and make sure all the transmission is proper such that we can collect the data that people are looking for. So we were doing that for the Starship launches, both of them. And I definitely remember before the first one, just the idea, we got to see the trajectory and stuff like that. and I read up just so I could stay like knowledgeable. But the idea that they were trying to build a rocket that was going to break apart and fly back to the launch pad just didn't really spark until I actually got to see the data and stuff like that and watch like from an airborne platform that's pretty close, watching it actually separate and like attempt to fly back where it got a lot closer, like on the second one and the third one and stuff. And I do think that is pretty crazy, like just pretty science fiction coming to life. Even though it's not fully like working the way they expect, just the idea of kind of having like, I don't know, I feel like autonomous cars are still something that just recently came about in my lifetime. But having like an autonomous rocket come and fly back for reusability and stuff like that is just really eye opening and takes a lot to actually get off the ground and stuff like that. So I definitely think that's probably my favorite in terms of the craziest, like coolest space exploration invention that's going on right now is, I guess, autonomous rockets. And there are a lot of places doing similar work, but I think that one is pretty crazy for sure.
Okay, so full stop. That is the coolest thing. Did anyone watch the Starship launches? Like, who want to watch them? Yeah. Okay, so those are amazing. Wait, so Kyle, was the camera that you guys had, was it the view that you saw from like the live streams of the rocket? Or were you guys watching the trajectory from like a more detailed camera view that wasn't public?
Yeah, so I'm trying to remember. I definitely don't want to speak out of truth or out of a lie, because I didn't know. I think for one of the observations, the stream that we had was live streamed. I can't remember if it was the first or second one. I believe it was the second one, but I was watching the launch from like our stream of it completely. So I'm not sure what parts of the launch they switched from like different camera views and stuff like that. We weren't imaging the third launch, so none of that like data is ours or anything. But the first and second one, one of those, a few of the like frames and stuff were ours. If there are any that looks like substantially closer to the rocket than the rest of them, that might have been coming from our airborne platform. But yeah.
Yeah, that's super cool. What was the platform? Was it a helicopter that you guys had the imagers on, or what was it? Drone?
It was an airplane. So they used an old airplane, WB-57, and I can definitely kind of put maybe a link to like my research group and stuff in the chat. But we image it from an airplane. We do try to image like off of Gulfstream, like private jets sometimes, and we were doing that for the OSIRIS-REx reentry. So when it came back, they were trying to assess how well the vehicle was going to perform the capsule. So we actually put our platform on a private jet and then took out one of the windows, put in a custom window that had the transmission profile that we were looking for and the bands that we were looking for, and went to go image that. But for Starship, we put the camera on the nose of the aircraft, and it has a gimbal system. So we use some like predictions about where it would be to point at it. Somebody's also like in the airplane and they're pointing at it to make sure that those are valid. And then we just capture as much data as we can. In both like flight 1 and 2, we got pretty good data of the actual explosion and stuff. And a lot of that stuff was used to like try to reconstruct. I think for the first one, they used it to try to figure out where like the debris field was going and stuff like that. So it's really interesting.
That's awesome. Yeah, that's really cool. I did not know that, but that is, you'll have to send the link because I definitely want to take a look. So yeah, so who wants to go next? Most exciting advancement in space exploration.
I'll go. Similar to Kyle's answer, I think the Artemis program and SpaceX Starship is the lander is going to take the astronauts down, and scheduled right now for September 2026. And that's got to work. That's our horses down to the surface of the moon. And Starship is going to change everything. I think still they haven't perfected, had 3 test flights. The 4th one may be coming as soon as May. But the rocket's almost 400 feet tall. It's the most powerful rocket ever built. And once they get this thing perfected, which I think SpaceX will do, it's going to change. It's going to be a game changer because it's going to allow more massive payloads to be carried to the moon or even Mars. And, you know, Elon Musk wants to eventually settle Mars with people with this rocket. So it's, to me, that's a very exciting time to see this right now. I got to agree with what, and you're pretty lucky to be working on that. So it's pretty cool.
Jim, so you said you were born in the 60s. Did you see the Saturn V launch on some of the later Apollo missions?
In person?
Yeah.
I saw the last Apollo mission when they docked with the Russians, when Saturn wouldn't be a little baby rocket compared to the Saturn V. I would trade I've seen a lot of Mars missions, space shuttle launches. I saw Artemis 1 launch in November of 2022. I'd trade all that for one Saturn V to the moon, though. I mean, I saw those on TV as a kid, but I wish I could have seen it in person.
Yeah, that would have been cool to see, and then to witness Starship when they perfect it and you can actually watch it successfully launch and land would be something. So I got to go to the Psyche launch in October, and that was the first rocket launch I'd been to, which was a Falcon Heavy launch. And that was really cool to see. You got to see the boosters land and everything. And after that, I was like, I am definitely going to go see a Starship launch, because it would make the Falcon Heavy look like a small little baby rocket.
Model rocket.
Yeah, model rocket. So I would highly recommend everybody at some point in the near future, but at least in your lifetime, sooner than later, go see a rocket launch, because it is extremely impressive feat of engineering. And when I was watching it, I was like, what's one of the coolest things about, you know, the space industry, and especially that the Psyche launch, is that we're literally just going there to explore. Like, there's really no other reason to go do that mission. And a lot of the missions, other than to learn new things, explore advanced technology and things like that. It was just one of the coolest things to see. So,
Was it a daytime or nighttime launch?
it was a daytime launch. Yeah.
I'm going to say everybody should see a nighttime launch, because it's...
Yeah, I second that. I wasn't there in person for Artemis 1 launch, but the fact that it was nighttime and seeing the imagery and stuff, it did mess with a lot of the analysis I had to do, because it was supposed to be daytime. But I think that's supposedly the people that were there, the Artemis 1 launch, like completely lit up the sky, turned like night to day. I think that's definitely, it's on my bucket list.
Did you see you didn't get to go to the Starship launch personally? You were watching it remote, or were you there?
Yeah, I was watching it remote. Some of my colleagues went out in person, and then I'm looking at like frame by frame a lot of the data. So,
yeah, that's so cool. You'll have to go to try to get out to the next one and see that.
Yeah, I know. I'm trying to see what they can do. I'll pay for my ticket and everything. Just make sure that I'm at the launch pad.
Sammy, Grayson.
Yeah, I can jump in. I've had the good fortune of working in the private side of space the last few years now. I'll say this, unfortunately, I had an immediate answer to your question that popped up, but I can't talk about it. So
You're gonna just be real secretive about it,
like
space lady.
Not quite, but this
It's live streamed. Okay.
So people would come after me.
Just cut that out.
I will say, so I'll take it. I mean, I think the rockets and Starship are huge. I'm going to take it to the other side and say some of the tools that have come out recently that are enabling a lot of this exploration and planning. Obviously, AI is everywhere. It's been great to see NASA and these other private companies embrace that. When I was at Langley, I worked with the Autonomy Incubator for Danette Allen, who's leading a lot of AI adoption across all of NASA. So she's I'm in Goddard. And it was really cool to see this company that, you know, historically relies on things built 10, 20, 30 years ago, really step in and start adopting some of these new technologies, everything from VR and AR, like we've seen in the lab, to, you know, using these more impressive tools and simulation and digital twins to simulate and prep for these missions. Tyler mentioned space lasers. One of the things there that I'm really excited about is just how we're improving our communication abilities in space. The big thing in the last few years has been optical telescopes and optical lasers, line of sight communication. Amazon Kuiper's doing it, SpaceX is doing it, MIT Lincoln Labs is doing it. They have their T-Bird satellite up. And these satellites are now able to transmit data at gigabit rates. And
not 1 gigabit like you get at home with Cox. I'm talking 100 gigabit, maybe even more than that. Approaching, the theoretical limit of what can be done. And that's huge as we start expanding further past our horizon, going out to Mars and beyond, just being able to relay back so much more information about what we're seeing, something that was not possible 5-10 years ago. So that has me really excited because, you could, once the tools are there, it's just a matter of finding somebody with the creativity to use them to, expand what we're able to do.
I'd love to follow that up. As someone who's always kind of working on tools and things in that sort of field, I was also gravitating towards those for this answer. And I think some of the most exciting stuff for me that I've seen is I think some of maybe like the business parks in space, the ISS sort of ideas that are going up, because on those, I was actually talking to someone at CES this year who, they're enabling the rapid growth of retina proteins so that you can basically bring that back to Earth in a mass quantity, which you couldn't do before, and help with vision issues. I think there's a lot of biological solutions that are being innovated in space, and usually because of that, just not having the pressure, it allows for different manufacturing. And I think that's pretty interesting as well. And even when we talk about like going to settle the moon or even further, some of the manufacturing ideas that are coming out of that, because I don't know how familiar everyone is with regolith, which is kind of like the top layer of the moon, but there's a lot of ideas to repurpose it into all sorts of things, from pulling houses from the ground with it, and to utilizing it for energy sources. It's really flexible in its uses, and so I think there's a lot of ideas for it, and it's really exciting. It'll be really exciting to see that actually happen and start doing those tests with it when we get those new tools out to space with the Artemis mission. So it's in sync with that. I'm excited with what's going on board for those Artemis missions.
That's awesome. Yeah. So a lot of really exciting things. A lot of what a lot of people don't realize is how much technology actually gets developed for the space industry, which then finds its way into everyday life, right? So from the advancements in semiconductor technology, which were heavily invested in by the Apollo program to build the computer for the first lunar landers, to things like the power tools that we use today, cordless power tools with brushless motors designed for
memory foam mattresses.
Yeah.
That's a new one. So the investment in the research and the development is critical to even just what we all appreciate with our technology. And there's tons of job opportunities in the space industry. So just like 2 days ago, you sent me that email from Astrobotics, which is one of the lander companies, which has one of the CLIPS lander contracts for NASA. They sent a list of probably 10, 15 job postings. So if anyone's interested, this week is actually Space Week at ASU, and the AZ Space Summit is happening starting tomorrow through Thursday. So we'll be there for that. So lots of great things, from career fairs and all kinds of things. But I want to do one more question for our panelists, and then we'll open it up for some open Q&A. So the last question, I have a lot more questions, but time, we have a time restriction. We got to stay on the schedule here. The last question is, if you had a crystal ball and you could see the future, what would be your prediction for a realistic timeline? I know NASA has one that they've projected for a sustained human presence on the moon and Mars, but let's break that down a little bit more and say, okay, what does that actually look like? How long before we have a sustained human presence on the moon? And then Mars obviously is quite, a bit out in the future, but let's see who wants to tackle that one.
I'll go first. Not that I know anything more than anybody else up here, but Artemis program, like I mentioned, the first landing since Apollo, it'll be over 50 years when it happens. It's right now scheduled for September 2026. Two astronauts, NASA astronauts, will go down to the surface of the moon, stay about 6.5 days. Most likely that date is going to move probably to the right, depending on what the Artemis 2 mission does in September of 2025. But I think we're going back to the moon. The funding is there. I think it's survived 2 different administrations. I think it's going to continue. Now, if the money has to always be there every year, which I know is kind of boring to talk about, but if you don't have the money, you're not going anywhere. But I think Artemis is here to stay. I think in terms of sustained presence on the surface of the moon, that's really start happening in the 2030s. These initial landings are going to happen, at the earliest 2026, and then Artemis 4 is 2028, and then Artemis 5 is like 2029, 30. So you can see you're already starting to get in the 2030s. But I think eventually these crews will go down, stay a week or so, and come back. But we'll start building the infrastructure for a base or a settlement there, a science outpost. And that'll start really getting underway hot and heavy in the 30s. The precursors before then will, of course, do a lot of work. But eventually, we're going to have like a base on the surface of the moon. And I see, on the space station now, crews go up for what they call increments, 6 months at a time. And then they come back down and rotate with another crew. I think that's going to happen on the moon, probably starting in the 2030s. Now, how long they'll stay, I doubt they'll start off doing 6-month increments, but maybe, a month or so, a couple months. But eventually, I think you see them getting up to 6 months, eventually a year, because you're going to need that when you talk about going to Mars. A trip to Mars right now, it's a 2.5, 3-year round trip. And most of that time is traveling there and back. You only spend a fraction of that time on the surface. Until we get nuclear rockets, which hopefully maybe one of y'all guys will perfect and get going here, it's a long trip with chemical rockets. Shortest you can get there is about 6-7 months when the planets are optimally aligned. So it's going to be a long trip to Mars, and you have to wait for the planets to realign to come home. That's why it takes so long. But I think the moon is going to be a proving ground or a test bed for going to Mars. Now, Mars, that's the plum. Everybody loves Mars, okay? But the moon is very important. There's a lot of science to be done there and a lot of technology and engineering to help us pave the way to go to Mars. I think sending people to Mars, it's always at least 20 years away my whole life, if not longer. I think that's the case right now. If the president came on TV tonight and said, we're going to have the funding that we need and we're going to land people on Mars, that's still 15, 20 years away, even with a blank check. So much has to be done. So I think Mars, like Tyler said, is down the road, but things can change, discoveries, inventions, things can change on a dime. So that's the thing about this field is nothing is static. It's always changing. And, like I said, I think the 2030s will start living on the moon. In terms of families going there, I think that's still always down the road. It will happen one day. I have no doubt. It sounds like Star Trek, but we'll be living on Mars. I don't know if I'll be around to see it, but I think you'll definitely see some of this happen. So like I said, some of you may go. I think our destiny is in the stars. We're going, and the technology's here. The question is, will this nation continue to lead the way? There are other nations out there that are chomping at the bit to take the lead. But I think this is something the human race is going to be continuing to do, is go into space, and it's a never-ending frontier.
Yeah, that's super cool to think about. If just to maybe comment on that or to get your input. So if, let's say tonight there was address the nation from the president and said, we're going to go to Mars and like we did to the moon in the next decade, right? Like they did with the moon. Do you think that is technologically possible at this point in time?
You mean within a decade landing on Mars?
A decade. Let's say it was the same thing.
See, you never want to say never, because you can be proven wrong, That would be very challenging, but great for engineers and scientists problem to work on. The problem is the funding again. If you had that blank check, things can happen. Apollo was an amazing event in history. No one saw that coming. It happened too quick. One of my favorite quotes was from one of the Apollo astronauts was like, the Apollo program is like somebody who reached into the 21st century and pulled back a decade and brought it to the 1960s. Because everybody thought landing on the moon would come much later. No one saw that happening in 1969. And in the 1960s, most people thought the Russians would be there first, okay? Because we were behind. So you never say never. Growing up, the Soviets or the Russians were our enemy. Now they're not necessarily our best friends right now, but we're up on the space station with them. They helped us build the space station. I never thought I'd see that happen, but it did with Apollo Soyuz. I was at that launch. Right now, we're not really cooperating with China, but that could change in the future too. I have a hard time seeing that changing in the near future, but it could happen. And as you can see, politics, money, Congress, all this stuff wrapped in with the space program. That's the beauty of the private companies like SpaceX and Blue Origin. These guys are billionaires. They don't care what Congress says or does. It's our money. We'll do what we want. And that's why, and I think we're seeing a lot of these, breakthroughs are happening because they're not chained with the stupid bureaucracy that the federal government has. It's like a plodding dinosaur, moves so slow. And, you talk about seeing the SpaceX booster fly back down. That was science fiction happening before your eyes. That's the 1950 science fiction movies you watch them. And it happened. And Elon Musk was told, it can never work. You'll never be able to do that. Now it's commonplace. And to me, that's still an unbelievable thing to see. And this big starship is going to do the same thing. It's going to fly back and be reusable. So, I don't know. It's just it's a great future ahead. And I think everybody in this room, you can play a part in it if you want to. That's the beauty of it all. Like I said, you could actually be an astronaut or be one of the engineers or project managers. There's so many ways to get involved in this. And I think if you have the interest, which I think you do, it's a trite saying, but the sky's the limit,
Yeah. One of the quotes I like to, repeat is that the only difference between science fiction and reality is time, right? So a lot of these things that you mentioned for science fiction are now reality given a sufficient amount of time, right? And as engineers, scientists, designers, we can make that time, shorter through the work that we do. So, yeah, that's great. Anybody else want to add to that?
I would.
Yeah.
Go ahead. Oh, okay. What you were saying kind of reminded me of my other answer before for something I was excited about, where anyone can kind of get into space. It's something else that's really exciting, and that has to do with more people getting into space, is that as things grow and develop, and as more people go into space, there will be more professions kind of getting involved with that because you have a greater diversity of things that are happening. So, for example, I'm an industrial designer. My actual job is a technology development designer. But as maybe we win proposals or work on things with people going to space, I'm going to be needed to do a lot more haptics. And then we're also going to be needing more people to work on maybe materials for people in space specifically. And so material science is already in space. It's just going to diversify, and those roles are going to keep kind of growing. And I think that is actually going to speed things up. I think there's going to be like 2 or 3 things that'll speed things up. I think it'll be that, and then I think it'll also be when companies are going to space, these privately funded companies are going to space, and they are going for exploration to find resources. And they do find resources because we already know that there are going to be some resources there. I think having that solidly will really, really incentivize a lot more private companies, a lot more, basically anyone with an interest in highly valuable resources. And there are some, such as, I think hydrogen-3 is one of them. And so I think it'll go through those kind of speed ramps. So I could see for the moon, I think also kind of around like 30s. However, on the other hand, with it, working in the industry and then seeing dates get pushed back, it's always hard to kind of be like, oh yeah, we're gonna make it on time. We're gonna be doing all this on time. I feel like each one might get pushed back 2 or 3 years, but then once you get the turnover of the goal of that mission, it'll re-incentivize, and it's gonna kind of build quadratically to your point where you don't know what's going to happen, so you don't want to kind of undershoot it because it's technology evolves quadratically. It's always on that super steep curve, and we're not really sure where we are on this, but it's going up. It's going up faster and faster, especially with AI. You're talking about working with someone in the program and integrating that in. That's just going to shoot it right up. So that being said, I think I personally would shoot for more like 30s or 40s, and I think that's more from a almost humanitarian kind of view, where I think about people settling in space and people spending time up there, and it is the most dangerous environment we know of, and so that's kind of something that has to be sorted out, and then from there, I think Mars will actually. I feel like the moon. I feel like the moon is almost more difficult than Mars because we have the proving ground of the moon. Right now, we don't have a proving ground. So besides the distance factor, yeah.
We don't have audio for anybody in Santan.
Okay.
There we go.
There we are. Yeah, we have it now.
I think Grayson also touched on a good point, which is it is going to take more than just the pure technology aspect of this. It's going to require us as a culture, as individuals, and as a collective to shift our focus. I mean, look at the Apollo mission back in the day. It wasn't just money, but all kinds of resources were being pulled into this. There was a huge boost in STEM education, people going and pursuing degrees in this field and getting involved. Industrial designers, NASA needs you pretty badly, I'll say. And anyone who's an analyst, anyone with a business background, anybody with any background. I think one thing we've seen that has been phenomenal in the last 5-10 years has been a real shift in focus for sustainability. And we know NASA's been on that since the get-go because there's only so many resources you have up there. They recycle urine in the toilets and turn it into water on the ISS. But it's going to take a big shift, a mindset shift, in order to make living and growing and thriving on the moon and Mars possible. And luckily, we're seeing that kind of change with, I don't want to sound old and say the younger generation, but with what's kind of part of the mindset today. And so, yes, technology is going to be crucial to get us there. But then once we're there, like, how do we establish a footprint? How do we make it work? How do we make sure we're not immediately landing on the moon and arguing over, what here is New Arizona and what here is New Zealand? Because it's very easy to slip down that way, and that will be detrimental to, this greater mission of exploration and growth.
I was going to say that's why we built the Lunar Rights software tool. It's just for that reason of the.
Oh boy.
So, Kyle, any last thoughts from you?
No, yeah, I'll definitely keep it short. I think all the thoughts so far have been pretty spot on to what I would have said. I think like before, yeah, the technology with a blank check, you could probably get there pretty much on time or as expected. But the blank check and the fact that doesn't exist, and like Grayson was saying with the delays, those just push things back further and further. There is also the huge collaboration gap that has to be fulfilled, not even on a border perspective, but on a corporate federal perspective and stuff like that. Everybody has to come together to achieve this goal. Getting to the moon and stuff in the Apollo missions is one thing, when the whole country or countries as a whole are collaborating and stuff for that effort and somewhat contributing, it was a space race, so you can't run a race with just one person. But now we're kind of faced with a new task of figuring out how we can actually take all these ideas and all these new frontiers that we barely have characterized in terms of these new data analysis tools and everything, and new technological advances, and put those to work just like we did before. So I would say to get to Tyler's question, on a timeline perspective, it is really difficult to say. 2030 seems like it would be or sorry, the 30s and 40s seem like that would definitely be a transition time from, okay, the moon is pretty good. Let's try to move on. But I think in terms of like settling on Mars, there are literally just things that we just don't know right now. If it were to happen on a linear stage, then I guess it would be like the 50s or the 60s where we would actually see like settlements on Mars. But I'm sure there are things that we're not completely aware of. And like we've been saying before, a lot of stuff that science fiction is happening right now. So I guess if we want a better answer on that, we can just watch For All Mankind or something like that and try to piece together a timeline that might be more accurate, which it definitely could be. I don't know.
Awesome. Yeah. Well, thanks everyone. Those are great answers. I'm going to open it up just for some questions, Q&A. Any questions from the folks here? What's that? Oh, one question. Yeah, we are on a very tight schedule. So one question. Who's got the question? Who wants to ask a question? Anybody? Yeah. All right. Miles. Yeah.
So y'all mentioned like Starship quite a few times. And I know Starship uses rocket fuel. Curious what your guys' thoughts are on ways or technology to economize satellite launch. In the 80s, there was Project Babylon and spin launch. Going on now is Starship is so much of the weight is fuel the way to launch.
So I guess for the people online, we might need that repeated back if that's okay.
Question was, is there a launch technology that where the panel is excited about that would help reduce the cost to launch for satellites and future missions, right? With the example being that Starship is a large amount of the rocket is fuel, right? Which is true because if you look at even the Saturn V, right, all three stages were basically fuel tanks and an engine, right? So, and then the payload was like at the very top, you know, the lunar lander module. So, yeah, any comments on that?
I think we're married to chemical rockets for the foreseeable future. Hope I'm wrong, but I just think that's the way the thing out there is nuclear rockets. And these aren't like nuclear bombs blowing up and that kind of stuff. It's a nuclear reactor heating gases like neon or krypton or xenon, super hot temperatures and expelling out the rocket nozzle. Once it's up in space, a nuclear rocket will not get you off the ground from Earth for many reasons. People are scared of the word nuclear, fallout, all this stuff. But I think that for going to Mars, we need to cut down the times for human factors. And I think there'll be a melding of chemical and nuclear, maybe solar also cells, these ion engines, mixture of all that stuff. But, I think nuclear is the way of the future now. We're stuck with fission right now. If we can ever get fusion, that's another game changer. But I've been hearing about nuclear fusion reactors since I was a kid in grade school. And yeah, we can do them in labs for milliseconds, but they're nowhere near being perfected for us here for a power supply on Earth. If we get that, a glass of water can power a city, for months at a time. It's something for people to keep working on, but I still got to temper it with reality. I've been hearing about it my whole life, and we're not that much closer, really. So I think the good old dirty nuclear fission, if you want to call it good, is the way to cut down on travel time for distances in our solar system right now. And, warp drive and all that kind of stuff. It's just made up stuff. But like one day there may be something out there like that. I mean, everybody's kind of touched on this. Science fiction spurs the science fact of tomorrow. And so, you don't want to poo-poo these things because somebody out here in this room right now could be working on a propulsion system that revolutionizes everything. And you're exactly right, Tyler. Also, it's all fuel. It's something called the tyranny of the rocket equation. And if you look at that rocket equation, you can't really beat the physics. And it's mostly all propellant to get a little small payload to where in Earth orbit, to the moon, Mars, whatever. And it's kind of until we can get away from the chemical rockets, we're kind of stuck there with that.
the interesting thing that Starship is doing is that they're refueling rocket concepts. I think that will help us use our current technology to go farther, right? Because so much of our fuel is spent just getting into orbit, and that's why the refueling technology that they're developing with the Starship, where they can put up a Starship that's literally just a fuel tank in orbit, and then it can refuel another Starship to then go. And that's why the base on the moon is a critical goal for us as well, because that is a base station for longer duration missions. So really exciting stuff. We don't have, I think, any more time today, but let's just go ahead and thank our panelists just for an awesome time. So thank you.
Thank you.
And I'll hand it off to Jasmine, who's going to introduce the next thing on everyone's agenda.